Hello YouTube, RJ. We're back on the bench. Another device I need for working on antique radio and tube equipment is a DIN bug tester. And for those of you that are not familiar with a DIN bug tester, basically what it is, it's a device that lets you use a incandescent light bulb, in this case a 100-watt incandescent light bulb, to limit the current going into the device. It takes advantage of that these light bulbs, incandescent light bulbs, have resistance when they're cold, and once you start putting current through them, they start to light up. The heat they generate turns around and causes them to increase their resistance quite dramatically. And so this kind of is a good thing for us, because when we plug in tube equipment and old equipment with old capacitors and stuff and we power them on, we don't know if we have shorts or capacitors that are fixing to pop or whatever. And what this does is it allows us to limit how much current can get in this radio. If there's a dead short, instead of the radio getting a whole lot of current, the bulb itself is going to use up most of the current and limit, what you get in the radio or the amplifier or whatever you're working on. So it's a safety device. So you'll see these used all the time. You've probably seen them. You probably know all about them, but I need one. I've got my auto transformer to allow me to adjust voltage up and down. This will be plugged into that, and then as I'm bringing the voltage up on this old equipment, I can watch the light to see how much current, make sure it's not drawing a lot of current, and at the same time it's limiting the current. So it's a very, very important safety device to have on a bench for that kind of work. So I need one. I don't have one, so I'm building one. I'm building a very simple version you'll see all over the place. Very easy, very inexpensive. So I didn't want to make this a really long video, so I went ahead and did a lot of the things that were going to take a while that I was still able to show you. So let me show you what I'm doing. Okay, so I have a standard switch, big box store switch you buy for 75 cents. I've got an outlet, standard regular 120 US outlet that you buy for like $1.50. And I've got a cheap plastic box that you would nail on the wall when you're building construction. This one had the arms out where the nail went into the 2x4, but you can see I've hacked them off. I went in and cut those off and got them out of my way. So this plastic box, I don't have anything that can touch and short and carry current. So this is going to be our enclosure. And then what I've got here is I've got the plate that lets you have 2 outlets and a switch. I went ahead and got a cord, made sure it was a polarized cord, and I cut it off. Didn't want it real long because it's going to be on the bench plugged into the auto transformer. I don't need a lot of cable. And I drilled a hole, and I have these strain reliefs. I've got hundreds of them from my days doing Christmas light stuff, where I used to use these in my enclosures for my Christmas light. So anyway, I drill a hole and I put that through, so maybe you can see down in there with a little help that I've got that down, and that's my strain relief, and here's my power cord. I've brought it in, and so let's look. I haven't tightened the strain relief up so that we could pull this out and really look at what we're doing. I'll put this over here. Let's look at what I'm doing here. So the switches are on and off. That lets you flip it on. If you see something on the light bulb, you can flip it off quickly. You don't have to run over to the auto transformer and turn it off or whatever. So it gives you a really quick on-off capability in the box right here. So what we have is, in our power cord, the black of course is hot. We bring the black in to one side of the switch, and then we bring the other side of the hot from that switch. When the switch is on, the hot will run through. We bring the hot over here, and this is the strange and important part. And actually I see something I don't like. I had put my little terminals on there and soldered them, shrink wrapped them, because I don't trust crimp terminals that much. Can I not get that in better? Let's see if I can get it. There we go. Get her a little farther in there. I like that better. Sorry for the diversion, but okay. So we have hot coming in from the plug through the switch. Hot comes out, but over here on this receptacle, I want you to notice something. The hot is not going into the hot. Remember, your shorter slots are your hot. It's going into the neutral. You say, RJ, why are you running the hot in there? Well, it'll become apparent in a second. On these outlets, there's little tabs, little metal tabs. I'm going to show you this side. I'm going to get up. I get told that I don't often get in where you can see well. So let me come over to this camera where it'll auto zoom hopefully and we can see. You see the little metal tab kind of sticking out right here? Almost looks like it's sticking out for a reason. Well, it is. It connects these two together. So it connects your hot and your neutral together. Well, the idea is you run a hot and a neutral and both of these plugs are active. That tab's there to let you isolate these. So on the hot side, I don't have it isolated. The two hots are hooked together, which I want. But I come to this side, and what I've done is I've broke the tab off here. So on the neutral, they're isolated. Very important. Get that tab out of there and make sure it's isolated. Bring your hot into the neutral for the plug that you're going to plug your lamp in. And this is something I haven't explained yet. I've got one of those little receptacles. It's not here. It'll be here in a day or two. And I'll come back and show you it all complete. But I've got a little receptacle for a light bulb. You screw a light bulb in, it plugs into two prongs, right? Make sure you mark one for lamp and one for load while you're working on it so you don't get confused. And bring your hot into the neutral, the larger slot side, the side with the larger slot for neutral. Bring it over there and hook it here. It can't connect to this. It's isolated. So it's going to come to this plug. When you plug the receptacle in with the light bulb, the power is going to go through the light bulb, going to come back down into your neutral side. We're using this as a resistor. We want it in series with our power, with our hot leg. It's going to come down after going through the resistance of the light bulb. It's going to come to here. Well, that's great because we want that to continue on and to energize the hot on this one. So by having these hots together, what comes through the light bulb and arrives here comes out here and runs to your load, which will be your device under test, your amp, your jukebox, your whatever you're working on, radio. So that means this one will then have a hot anytime the switch is on and the light bulb's plugged in and it goes through, okay? We need a neutral, so the neutral off the power plug coming in connects here. So this outlet, the load outlet, gets its hot from the hot of this one. It gets its neutral from the power cord. And by doing that, we've just built a very compact, easy to use, simple device. Turn on the switch, power runs through the light bulb and out this plug. The only place your white neutral on your cord is going to go is to the neutral of the load. The lamp doesn't have a neutral connected to it anyway. That's it. Plug your receptacle in, put your light bulb in. I'm going to go ahead and I'm probably going to glue the receptacle in here where you can't take the receptacle out of that plug. But I'm also on the plate. I'm going to try to do a reasonable labeling on here. Which one's the lamp, which one's the load, what's on, what's off. So basically all I have left to do at this point is to pull my cord back through. Let's get our cord pulled back through here. And mount up the switch and the outlet. And then tighten up my strain relief. So I'm going to pop these in real quick. And I'll be right back and show you what I've got. Okay, we're back. I've got the everything mounted. I've got my strain relief tightened up. Switch in place. Flip up, turn on. Flip down, turn off. Load marked. Probably going to label it. The biggest trouble with these is getting incandescent light bulbs in the States has become quite the challenge. I found that with the ban of incandescent light bulbs here, it's very, very difficult to get it, to get them. What I've let me give you a close-up zoom here. What I did is I found that on Amazon that apparently they're still able to sell incandescent rough duty bulbs for trouble lights. There must be like a waiver for that or something. So that's what I have. They're a little more expensive, but I've got a 2-pack of those coming so that I can, nice thing is it'll be a rough duty. If you bump it around a little bit on the bench or whatever, the element's probably not going to pop very easily because, them trouble lights, they were fairly tough. You could drop them a little or whatever. So anyway, that's it. That's our dim bulb tester. You'll see this in use later. In just a minute, I'll come back with the socket and the light bulb in. Okay, here we are with the finished product. So not to epoxy it in. Instead, I just hot glued around the base to keep it from anybody inadvertently unplugging this, not understanding what they're dealing with. Make sure that always has a light socket in it. If you take the bulb out, it's no danger. Our circuit's open. So that's it. I didn't go anything fancy marking, just a permanent marker. And yeah, got our cord. We're good to go. So keep us safe when we're working on equipment.